My name's Evan Statton. I'm a broadcast engineer by trade. I've been repurposed as an AWS SA specializing in broadcast television. I want to thank you for being here and choosing red. Red is the right color. They don't know what's up, so thank you. I'm joined by Alistair Hamilton. He's the SVP of Distribution Architecture, Media and Broadcast at Fox Corporation. Together, we're going to show you what Fox is doing to change the TV industry with AWS. Before we do, I want to introduce you to some of the brands that you interact with every day when you think about Fox. Some of you may know that a large part of Fox was purchased by Disney earlier this year. So this is a reintroduction of Fox Corporation, if you will. So stand by.
Something is coming. This is the beginning of a new era.
You have probably heard by now there are some major changes coming to the media landscape.
And that new era is defined by a new wave of talent.
I want you to remember something. Let's see what you got, Fox.
It's time right now to take the next step on our journey!
All right, so let's do it.
It's awesome. Come on!
Did you know?
Policy and procedure be damned.
Whoa!
You guys ever dealt with anything like this before?
You gotta have faith.
I love this job.
We have to think about moving into the future.
We begin tonight with breaking news. We want them to know that they can trust us.
Our lives are shaped by relationships.
No one's ever been this nice to me.
It's who we are.
Ladies and gentlemen, we are proud to introduce to you our family.
So that's new Fox, and now everybody's headsets are way too low. We're going to have to work on that, huh? I always like to level set everybody on what we're talking about a little bit. And I usually do that by telling a brief history of the television technology as we know it. Television was invented by a lot of people. And I was taught in high school on my first TV class that this fellow, the fourth from the left in the glasses, Philo T. Farnsworth, I was taught that he invented television. It turns out it wasn't just him, he had a lot of help. Everybody up here was responsible. The fellow on the left, Carl Braun, invented the CRT, actually, the cathode ray tube. And they used to be called Braun tubes. And John Logie Baird, is the second, and he was the father of mechanical television, a device that used a wheel with slits in it to display an image. All the way on the bottom right here, these two gentlemen, they're responsible for inventing the OLED screens, of which we all have them in our pockets at this point, and TV has just exploded in this way. And so this progression took about 100 years. Philo patented his electronic television set in 1927. 12 years later, it was presented at the World's Fair. And the first network came online about 8 years later in the United States. Color TV was introduced in the 50s by adding a color subcarrier. And in 1969, Neil Armstrong walked on the moon, and they had the largest viewing audience ever to that point. The reason I mention that, of course, is because it was in that moment that there was a global broadcast that brought people from all over the world together for the first time, and it's at that moment that it was realized that television could really bring people together in this way. Finally, in the 90s, television moved to digital and HD formats. And around that same time, if you consider this orange line that's coming up, that represents the founding of AWS. And so what we start to see beginning in 2006 is a merging of software as a service with video codecs that can run in real time in software. And in 2017, AWS Elemental launched the native console media services such as Media Live at reInvent. And it's now in 2019 that these two stories have merged into a place where broadcasters such as Fox are ready to migrate their critical live workflows to the cloud. And I think the point here is that we're at a moment that's critical in the history of television. Things are changing very rapidly right now. Broadcasters are looking to take advantage of new technology and be able to move quickly and scalably. And the software offered now is able to do that. The first image ever displayed on television by Philo's electronic television was this. It's a $sign. This was to his investors. They came to his little lab in San Francisco one day, and I said, "What's this all about, Philo?" And he showed them this through the air, and he said, "This is going to be a big deal." And he was right. A couple of years ago, we measured the industry at over $300 billion globally. And here in the US, we have about 22.5% of the market share. I guess the gap between 22.5 and 29 is what, Canada and Mexico, I suppose. But a third of the market is right here in North America. That's the point. So today we're going to talk about what's happening next. I told you about the last 100 years. Let's talk about the next 2 years, 3 years, if you will. I'm going to show you how broadcast television has worked in the past. And Alistair's going to teach us about their transformation, what they're doing on AWS to change broadcast television. And then we're going to talk about what comes next. And so how has it worked? Well, the broadcaster's job is simple. Not really, but the basic idea of this is that a broadcaster aggregates live content such as sports and news. They aggregate studio productions, and they aggregate advertising, and they put them together in a linear sequence that we call a channel. And those channels are distributed via broadcast affiliates, such as your local Fox affiliates, your MVPDs, such as cable head ends, if you have Comcast, Charter, what have you. And of course, at the bottom, the newest addition to this list, the digital MVPDs, such as Hulu or Sling. So again, live television, channel playout is the term we use to describe the playing out of that linear channel with shows, documentaries, integrating the commercials, what have you. And then the delivery aspects to the MVPDs and over the internet. What do broadcasters worry about? This is an interesting one. It's a very basic slide, but it's a very important idea here. We talk to a lot of broadcast TV customers, and the thing that we hear in every single conversation are these topics. They care very deeply about latency. They care very deeply about reliability. And they care deeply about video quality and reasonable cost. And if you can't do all four of those things, they don't want to talk to you. So we at AWS had to work to step up to make sure that we were checking all of these boxes. And this was good enough for a long time. Excuse me. And then the pace of innovation picked up, and flexibility got added to the list. And what this means is that broadcasters and other customers are less willing to get locked into long hardware refresh cycles because new video codecs come out, because new container formats come out, because new instances come out, you name it. They want the flexibility to be able to scale up and down. And the cloud is great for that. So now I want to introduce Alistair again, Alistair Hamilton from Fox. He's going to walk us through what Fox is doing to change HEVC.
All right, thank you. So my name is Alistair Hamilton. I oversee distribution architecture for the company. I've been in the distribution business pretty much all my career, 10 years at Fox, the previous 18 at Turner, and then stints at Intelsat and at NBC News prior to that. But certainly the last, almost 30 years in the distribution business. Let me just start by saying that, we're very excited to be working with Amazon on this project. It really is sort of groundbreaking stuff. The move that we're making to HEVC is not in itself newsworthy. Others have done that. It's really the execution of how we're doing it that is we think is newsworthy. Using the cloud for encoding and multiplexing, which has not been done before. It's been done in a different way. So we'll go into more details. We've been discussing the HEVC move in Fox for many years. Our current hardware is 12 years old, and it's pretty much end of life. And so we knew that at some point we'd have to make the conversion. We didn't really want to do an intermediate form, so by waiting, as long as we have, we can jump straight to HEVC, high efficiency video coding. And I know there's probably a bunch of broadcast folks in the room, so I apologize if I'm sort of talking at a lower level. But we really need the ability to do additional new things: dynamic ad insertion, 4K, ability to deliver, via methods other than satellite, which today and for many years has been sort of the primary sort of mechanism that we've used to deliver. So this is a critical project for us. This is really core infrastructure for Fox. This is how we deliver all of our content, other than the streaming side. This is how we deliver all the linear content to the broadcast industry and to the cable industry. So a lot is riding on this working well. And as Evan said in the prior slide, reliability. I mean, this has got to work. There's no sort of room for failure. It has to work 24/7 without question. The flexibility that he mentioned, which was kind of the final bullet on that slide, was really interesting because of the nature of the cloud and the ability to spin up and spin down encode and multiplex instances. The old days of buying racks of equipment, which sometimes you didn't need 24/7, so you burn capital. In the case of the cloud, we can spin something down, and that's sort of opens up a whole new realm of possibilities. I mean, the quality of the video and audio goes without saying, right? We have to have that. That's not even sort of a negotiation. And the latency is obviously important too. I mean, we're very much in the live sports business, as you saw from the reel. And there's nothing worse than somebody watching in a household on a television and someone in another room watching on a different device, and all of a sudden start shouting and screaming and clapping. I mean, it kind of and then 30 seconds later the picture catches up on the television. That's not a good situation. So we have to. So latency is to our friends in sports is a very important topic. So before I get too far down the line, I mean, I'm sure many of you here are familiar with Fox in some form or other. Certainly if you're sports fans, you'll know the name. But just spend a minute or two on the history of the company, because it really goes back, almost 100 years. 1923, the first sort of roots of the company were formed. Actually in Australia, but when a company called News Limited was formed, and it was a newspaper publishing company. In '49, the Murdoch family, who still own the Fox Corporation, the part that I work for, bought a minority interest in News Limited, and then in '52, Rupert Murdoch, who is now the current owner of Fox Corp, when his father passed away, inherited the interest in News Limited. Gradually began to build the business over the next 20-some years, acquiring magazines and newspapers all over Australia. And then expanded in '73 and actually bought a newspaper in San Antonio. So that was their first sort of foray into the US market. News Corp as a holding company was formed in '79. That was sort of that name has sort of stuck with the company for a long, long time. The Fox name enters the sort of picture in '84 when News Corp acquired 20th Century Fox, the movie business. So that's when the Fox name entered the picture. A year later, Mr. Murdoch entered the broadcast side of the business by buying a company called Metro Media, which had TV stations and a syndication arm. And then a year later, from there in '86, formed Fox Broadcasting. So now, here we are now solidly in the broadcast business from '86. Continued to build the business, acquired stations, et cetera, et cetera. '96, Fox News was founded. '03, Mr. Murdoch bought a 1/3 share of DirecTV. the DTH provider. He sold it 5 years later to Liberty Media, but at least for 5 years was sort of in the DTH business. The Fox Business Channel was formed in 2007. 2013 was a sort of a pivotal change because the company had grown, and in order to maximize shareholder value, the decision was made to split it into two parts. News Corporation took the publishing side of the business, and 21st Century Fox took the media side of the business. So now we're sort of running as two separate companies. All of us were in the 21 CF, and there's one more bullet, I guess, on the next slide. Yeah, 2019. So this was earlier this year, a very important change. As Evan mentioned, Disney acquired 2/3 of our company. The 1/3 that remained, in sort of the Murdoch ownership is now called Fox Corporation, and I'm part of that. And we retained a number of channels. The Fox Broadcast Network we retained, Fox News and Business, and then a ton of live sports stuff, Fox Sports 1 and 2, some soccer channels, Deportes Soccer Plus, Fox Sports Racing, which actually is generally a Canadian channel showed in Canada. And then we did retain one regional sports network. We actually sold more than 20 to Disney, actually, which subsequently went to Sinclair. But anyway, we retained one, the Big Ten network. So we have one out of Chicago. We have one regional sports net. These are the logos, which I think you guys are probably familiar with. The top left is the Fox network, the main TV network, and Fox Sports and Big Ten, et cetera, et cetera. So again, I'm sure those are familiar to anyone that watches our channels. Just in terms of, give you some idea of scale, we have over 1 million assets stored in the cloud, 60,000 hours of raw content we handle annually, and 16,000 annual live event hours. I mean, we could go into great detail. We do probably 100 to 200 live feeds inbound every day of various flavors. So it's a big operation. I mean, it is a sort of big content machine for sure. So let's talk about. We're going to show a video actually. We about, I don't know, 2 weeks ago, 3 weeks ago, I guess it was. We made a short sort of behind the scenes video which we thought you would find interesting. We picked an NFL game. It was a 49ers Cardinals game that was played in Levi Stadium in San Francisco, and we sent a cameraman to the field. We also had a cameraman in LA, expert, and filmed some footage in LA.
I don't know if I'm a cameraman expert, but thank you.
It worked out very well. So we have about a 6 minute kind of behind the scenes video of how the signal flows from sort of the source, all the way through the chain. So with that, we will roll, and I will talk through the video as we go. All right. Clearly the stadium. We actually were filming about 2 hours. 2 hours before the game, roughly. We didn't want us on the field during the game itself. So obviously, tons and tons of cameras for a game like this. And you'll see just a ton of different shots. This is a dolly with actually two cameras. You can see the two cameras on that one dolly. One is typically for broad, wide shots, and the other one is usually following sort of an individual player, but they're on a common dolly. These things you've seen, I'm sure, when you've watched football, these parabolic mics for picking up natural sound and some of the calls on the field. By the way, the lower left corner is sort of where this is in the flow diagram, which we'll go into in more detail. So this is the access point at the stadium. This is sort of a permanent fixture. We roll in a production truck, and this is where we couple in, with the triax and the fiber. The cameras are all communicating back to this point with uncompressed video, 1.5 gig. So now we're in the production truck, or going into the production truck, which is quite a multi-million-dollar truck with sort of massive slide outs, like imagine sort of an enormous RV, except really enormous. So this is the audio section with all the audio patching, and you'll see the audio switcher there. Obviously no one there right now because it's a couple hours prior to the game. And we work our way through the truck as we go. So this is sort of the main sort of production control room in the truck itself, where the director sits and the assistant, the AD, and sort of others involved in the production itself. So you can see There's the TD with the switcher, sort of camera shots, etc. And they're just getting ready. Again, 2 hours prior, just checking out all the lines, checking out the timing, and they go from camera to camera. They don't want, a glitch, so all that's got to be timed, and it's quite a bit of work. So they're working on this several hours before the game. And then this is the end of the truck, the sort of the distant end. This is the EVS replay section where the guys, you can see the rotary knobs on that controller that sort of controls the speed of the replay. So these guys are doing all that in the truck. And this is the shot of the truck itself, right? And the bay on the truck, that is the interface there. So you can see all the cables coming in. It's obviously quite a lot of work to get it all fixed up. And then here's the fiber interface at the stadium. We will typically book at least one fiber, sometimes two for a big game, as well as satellite back from the venue. So now we've moved to LA. This is our transmission ops facility in Los Angeles, where the feeds come in from all the venues. There are small sort of QA stations where there's, an engineer that's watching the feed to detect if there's any issues with it. You'll see in a minute or two, we go to one of those. This was actually filmed, if I recall, during the actual game. So you can see the logo on the field.
Yeah, that was the kickoff.
Oh, was it? Okay. Yeah. So this is during the actual game itself, and this is the little sort of pod where the guy will QA the inbound feed, and we'll let this progress through. We were allowed to take some shots in the studio. So now we've kind of moved to the studio piece. Obviously, if you watch Fox NFL, you'll know there's pre-game show and the halftime show, etc. So this is the studio where that is all done. Again in LA. So you can see the cameras and the video wall that we use. And obviously, everything that goes on there is fed to a production control room, which is here. So again, there's a really big switcher with the TD, and the director's out of shot there. But anyway, this is the main control room for Studio A, the main NFL studio in Los Angeles. So now we're back in TOC. We're going to have a shot in a minute or two of a net room, a network room, and there's one of these for every game. I guess we cut that out, right? So now we've jumped to the equipment rooms, and the business is at least to date, been a very hardware-intensive business. But the point of these shots is that racks and racks of equipment that we're showing you in this shot are actually going to go away when we're done with this project and we've moved stuff to the cloud. Many of these racks will simply not, they'll be empty because the functions that we're doing here will be done in the cloud. Now we're riding on a golf cart, which was actually a death trap of a machine. Across
that
the
bad.
It was. The thing was lethal.
It worries me that you were that afraid and I was the passenger.
So this is shots of the uplink, right? So again, our distribution for linear networks today primarily is a satellite, and so you're seeing shots in the earth station here of the amplifiers and the dishes, etc.
I want to pause for a second. I want to point something out. We didn't point this out yesterday. Sorry for interrupting.
No, go ahead.
I don't know if anybody has noticed, there's a T plus 1.8 seconds in the diagram right there. That's been there the whole time as we step through the workflow. That's the latency since the actual live on the field. So everything you've just seen, all the rooms, all the production, all the studios, it's all gotten to this point in the signal chain after about 1.8 seconds. And I just want to impress upon you when we talk about how latency is important, this is the type of latency we're talking about for low latency.
Yep.
Sorry, go ahead.
No, go ahead. No, that's good. That's good. So there's, waveguide out to the dishes and obviously up to the bird. Talking about latency, obviously the satellite adds another half second. I mean, that's the cost of sending a signal, 22,500 miles up to the satellite and then the 22,500 miles down.
I did the math, actually.
You did?
Light,
tell me it's like...
It's less than half a second.
Yeah, but just, right?
Yeah, I mean, it's,
Yeah.
You start, you get to do this. We get to fly with the...
So now he's got some fancy graphics here to, courtesy Google to zoom up, and this is just some specs of one of the birds that we use. We use Galaxy 3C and Galaxy 16, two geostationary satellites for our transmissions on the broadcast side, and you can see there some of the details. And I think zooms back down. Yeah, it does. Very cool. There we go, almost. All right. So this was a diagram that we were looking at right before we went into the video. Just a couple of points before I forget. So we're bringing back the video from the venue. When we use a terrestrial path, it's using JPEG 2000, 150 megabit iframe, low latency for those that are sort of into that stuff. And that's pretty much covered most of the details there. So this next slide, again, is a similar slide there, but sort of focuses on the area that we're going to talk about, the encode mux piece and the transmission piece that's in the red. Okay, so here's where we get into the real sort of details. We're going to drill down now into some of these different categories, the affiliate category, MVPD and DMVPD, in a bit more detail. So again, you can see the left-hand block, Los Angeles, and the various steps there. So if we go to the right-hand sort of group of three and go to the top one, broadcast affiliate. There are 3 satellite receivers at each broadcast affiliate. One is really for promos and other things. There are 2 that we use. We send the signal sort of twice, essentially, through 2 different paths to the station continuously. So the IRDs are going to take that information. They're going to pass it as a transport stream into the rest of the processing of the station. One important point to note is that the Fox stations, we do 2 hours of sort of network programming every day, but then the other 22 hours are local programming, local news and syndication. So we're only doing 2 hours of network content, unlike the other 3-letter networks that are doing 10 hours, 12 hours. They tend to do more. Right now we're just at 2 hours. So local automation is doing the play out for much of the local stuff, local ads and any other stuff that they're doing, syndication stuff. Then it goes through the other station, the other parts of the station, the other processing to modulate and out. The OTA is the over-the-air transmitter to the stick. Many of the stations do also fiber directly to local cable operators, and sometimes they'll actually have servers creating bespoke local ads so that the cable viewers don't see the same ad that they would see over the air. So there's an extra sort of revenue stream there. The next one down to the MVPDs. So these are the cable operators that you guys all know: the Comcast, the Charters, Southern Links, et cetera, et cetera. The production, for them is the same, of course, on the LA end, and we deliver via satellite and to some via fiber. They're taking in obviously, a stack of networks, right? A dozen whatever networks. That is basically transcoded down and basically repackaged by the cable operators. They'll create their own package of channels to fit in a 6 megahertz slot. They typically use what is, you see on the diagram here, 256 QAM, if you can read those numbers. That's the QAM is the type of modulation the cable guys use, because they're running in a fairly low noise environment, so they can use QAM. We couldn't do that on the satellite side because it's too noisy. So anyway, 256 QAM will get a package of programs, 38.8 megabits actually worth of stuff. So they can get a lot of content in that channel, and then it goes down their infrastructure to their cable set top, the cable boxes. Then the last one, the DMVPDs. This is where we get into the streaming side of the business. We're typically not delivering actually by satellite to those guys. It's usually a terrestrial delivery through various different means. But the important point here is that it's converted typically to an HLS stack. So there's going to be a transcode and a packaging exercise that is done. We use various different companies to do that for us. And then it goes out on a CDN to the end user. And it's, again, this is an over-the-top play typically. Through a broadband connection.
Yeah, excuse me. This is, when you think of web streaming in the cloud, this is the part that's been available so far. We're talking about the other 2 and the broadcaster themselves here, but the majority of the latency, like we were just talking about, that handoff out of the encoder in Los Angeles to the DMVPD is seconds after something happened. The majority of the latency from when you're watching something on the internet happens during that pipeline right there.
Yeah. And we've, on some of our streams, we've seen 30 seconds or so latency. So that's the killer, right? There's just so much processing. By the time it's been repackaged and gone through the CDN, it takes just a long time, and then we end up with a big time delta between the true live signal and the stream delivery. So this actually is a quick drill down on the MVPD side. Again, you've seen that in the previous slide, that middle box. That there is, that there is an opportunity now in this new world when we're moving to HEVC, where we want to move away from just satellite delivery to potentially delivering through a terrestrial means. And so we'll get into details in a minute, but we're introducing hardware that can take not just a satellite feed, but it can actually take a terrestrially delivered feed as well. So that's important. All right. So we'll let this thing build for a second. So this is interesting, at least to me, because it's the evolution of codecs, of coders and decoders over time. So in the 1990s, MPEG-2 was sort of proposed and actually ratified by the ISO as the standard for digital television and for DVDs. It's still very, very widely used now. It's been a rock solid standard. It uses a compression algorithm called discrete cosine transform, which is extremely efficient at decoding, because consecutive frames in a video stream have a lot of redundant information, and the DCT transform is great at basically figuring out what's redundant and essentially, not processing it, or at least not in the same way. MPEG-2 does have some limitations, though. A frame is broken up into blocks, and MPEG-2, pixel blocks of say 8 by 8. MPEG-2, the spec only allowed for one sort of a fixed block size, and that frankly became a limitation. It could only do a certain type of sampling of the chroma, of the color information in so-called 420, and that was a limitation as well. And could only handle up to 4K, but back in the 1990s, no one was doing 4K, but that was its limitation. So, and then going down the timeline, I mean, AC3, you guys I'm sure are very familiar with. That's, Dolby, that's 5.1. Surround, that was spec'd out around the same time, 91. MP3, which obviously is a very common audio encoding standard or format, in 93. AAC was actually sort of a holdover from the old MPEG-1 days, MPEG-1 Layer 2. It was a very good audio encoding technology, so it was sort of kept in use to some degree. AC3 is certainly by far the most common. So in the 2000s, actually 99, 2000, the standards bodies decided to come up with a replacement to MPEG-2, and it was MPEG-4. And the important thing is it's twice as efficient as MPEG-2, so same quality for half the bandwidth, if you want to look at it that way. Over the 90% of the broadcast industry now uses MPEG-4. It has become a very, very common standard. It had a kind of rocky start at the beginning because there were probably around 100 different entities that had contributed to intellectual property, and they all wanted their piece of the pie. So the MPEG licensing authority was kind of a mess, but it got cleared up and it got adopted. Go back just a second because there's a couple more. A couple important differences. MPEG-4 made up for that MPEG-2 sort of suffered. It allowed variable block sizes for sure, multiple motion vectors between blocks, which was super important. Some very clever sort of context adaptive encoding technology was also introduced, which was very, very helpful, very impressive. And it could handle resolutions up to 8K. So that was a number of really important steps. I'm going to jump quickly into HEVC. So 2013 was when HEVC, high efficiency video coding, was introduced, which is what we're going to use for our project. And really was an extension of the concepts that had been used in MPEG-4. Again, it was a quantum leap. It was twice as efficient as MPEG-4. So given that we today are using MPEG-2, we're now at 4x more efficient than MPEG-2, which is huge for us. So we can go down to essentially the same quality for a quarter the bit rate, which is a really big jump. HEVC introduces a whole load of new tools. It's not just discrete cosine transforms, it's additional transforms. It's a lot more complex to encode, though. 10x at least more complex than MPEG-2 to encode. So that's where the cloud comes in, I think, very effectively, right? We've got massive compute resource available to us, and so this is an example. And then I put in VVC at the end just because this is sort of what's next, right? So Verstar video coding is a standard that's in development now. It won't be available even in sort of early form until the end of 2020, and I think commercialized, a year or two after. But it's in the pipeline, and it promises 30 to 50% better than HEVC even. So, we're getting super efficient with this whole thing. Before I just leave this slide, Two quick comments on the ATSC, the stuff in blue. ATSC 1.0 is the current over-the-air broadcast standard. Was introduced in 09. In fact, it was mandated actually in June of 09. Stations had to go digital and they had to adopt ATSC 1.0. MPEG-2 is the specified video encoding format for ATSC 1.0, AC3 5.1 for audio, and it's done pretty well over these years. But now we're looking at introducing a new standard for broadcast, ATSC 3, which is still sort of in the test phase. There's certain markets, Phoenix being one of them, where we are certainly involved in testing. It allows 4K at some quite high frame rates. It allows immersive audio, AC4, MPEG-H. So it's pretty impressive what it introduces. And in the interest of time, I'm going to skip the other stuff were other codecs that were developed along the way. I think at that point we're going to pause here, right? And do you want to
actually
talk for a minute?
You know what I think we should do? Let's do this slide and the next one, and then
Okay, cool.
then I'll do it.
We have something cool to show you that we didn't do yesterday, but we got a little daring after yesterday, so we're gonna try something see if we can get it to work. And I won't steal your thunder, so I'll let you.
We didn't get daring. We got feedback. That was, wouldn't it be cool if?
True. So we decided we'd get daring and try. Anyway, so let me talk about evolution of encoding technology. So the system we use today was, as I mentioned, 12 years old. So I introduced in 07, and the photograph on the far left is a photo of one of the encoders we use. It's a single channel, one rack unit box. It'll do essentially a single MPEG-2 720 stream. So when you have multiple channels, you just have racks and racks of these things, right? So that's not the most efficient use of space, but it's frankly done a very good job. Been super reliable for us over the years. But as mentioned, HEVC is very compute intensive. So there's no way a box like that could handle it from that sort of generation. So fast forward to 2016, and we've done some testing with some servers. This is one example of servers that we use actually in a different application, but I'm going to use some of these to do HEVC encode. And the box in this picture is actually an HP DL380 Gen 9 box that'll do 4 HEVC encodes. Uses an earlier version of a Xeon chip. But it does a reasonable job. Jump to 2018, and that's actually the photograph of the front and rear rack of an Elemental Live encoder, which is Gordon Moore, right? 2 years on, it'll do a lot more than the 2016 box. It'll do, I think, 8 HEVCs and a 4K Ultra HD in that one box. Then, of course, the final jump, 2019 to the cloud. And this is where we get the benefit of just massive compute capability to do HEVC, multiple channels, as well as 4K. The cloud, and I think one reason we're so excited is the cloud lends itself to this because of it's just a huge amount of compute resource, but also the ability to spin stuff up and down. Today we don't have a 24/7 4K channel. I'm sure that will come in the future, but we'll do 4K on an event-by-event basis, and the ability to spin that up and down is tremendous. I mean, rather than me going out buying racks of 4K encoders that sit dormant for 11 months of the year. So that's really big. So stat muxing is the other piece, and this is really, really new because stat muxing has not been done in the cloud until you announced a week ago. I don't know how new this is, but it's super new, right?
You're the guinea pig.
That makes me feel really good.
Well, you almost killed me on a golf cart the other day.
So back in 07. The stat muxing was really all done in hardware with hardware acceleration, et cetera, and that's a photograph of the transport multiplexer that we use today. For those not familiar with stat muxing, the stat mux is basically taking in multiple channels. In the case of our HEVC project, we're going to do 8 channels in a transponder. So we've got 8 encoders all working away furiously, encoding the video, all feeding into the stat mux unit. And that unit's basically got a multiplex, got to mix all these streams together. But it has an important limitation. Its output has to be a fixed output because it's got to go on a transponder that has a finite pipe size, right? I mean, in our transponders today, 68.046 megabits, if you want the actual number, that's the information rate of one of our transponders today. So that stat mux has got to put out a combined signal, video, audio, metadata that fits into 68 megs. And so what it does, and again, extremely clever and very compute intensive. It's the StatMux controller is talking back to the encoders, which are one stage upstream, and instructing each of the encoders to encode at a different bit rate on a frame-by-frame basis. So encoder number 1 is told to encode at this bit rate, number 2 at this bit rate. And in real time, essentially, the StatMux controller and the encoders are determining the complexity of the program, the complexity of the content, and adjusting so that, you know, the NFL game, the NASCAR race, something that's very compute intensive and bit intensive gets the bits, and a talking head is the opposite, right? Doesn't need much because there's really not a lot changing in the picture. So there's a lot of, you know, so-called closed loop StatMux, right? It's StatMux talking to encoders, and that's a lot of compute going on. So and this is an MPEG-2 StatMux, by the way, you see in the photo. So now 2019 in the cloud, you know, ton of compute. StatMuxing is now possible in the cloud. We've seen it, you know, and you'll see it actually in a few minutes. And it's super impressive. The quality's great. We have an 8-channel multiplex that we're going to show you here, and it's very impressive. It really is. And this is the first time it's been done. That's why we're very excited about it.
So I'm going to demonstrate this for you. This is the part that we didn't do yesterday. We did indeed launch the StatMux feature as part of the Media Live console service last week. And I've had a pleasure playing around with it. My background, before I worked at Amazon, I worked at NBC, another big broadcaster in the US, and I built StatMuxes much like Alistair did. And when I touched this thing, it was a pleasure to use, and I'm going to share with you that now. This is the first presentation publicly of somebody building a StatMux in real time, if you will. So what's new here? It's this right here where it says multiplexes. It's hard to see. But if you go here, it'll load your multiplexes. It takes a second. We're not going to sit through the entire creation and wait for it to start. We'll go back to the presentation for a few minutes and we'll show the progress. But the goal here is that by the end of this session, within the next 17 and a half minutes, we're going to have a brand new StatMux of Fox channels that's never existed before. Okay, so create, just so you know that I'm not using anything pre-canned, reinvent. We're going to choose our availability zones here in 2A, 2B, transport stream ID, I don't know, 101. How about that? Bitrate, let's do 45 megabits per second. We're going to hit create. It's creating it. And while it's doing it, now you see here, so this is where you add your programs to the StatMux pool. So Alistair was explaining that, you know, you run multiple programs. If you're running sports against news, for example, the sports gets more bits than the news because it's faster action. So I'll just create a program here. I'll just call it R1 for reinvent 1. We'll give it program number 1. Create. Channel missing. Okay, no problem. We'll add a channel in a moment. So what that did was it allocated this channel within the MUX. And now I'm going to create a channel that's going to attach to this multiplex. I'm going to call it R1. I'm going to use my Media Live ARN. Standard channel is fine. The input to this happens to be a HEVC 50 meg. We're sending 80 megabit contribution streams from Pico up to the cloud for this. And then what you do, if you're not familiar with Media Live, is you add an input. So I'm going to add reinvent input 1 that I created. I'll confirm that. And then you go to your multiplex group, you go to your output, and there's a couple settings that you got to put in here. I'm going to put, it looks like maybe they filled in for me. I think it makes me put the frame rate. So 60,000 over 1,001 is 5994, which is what we do here. If I hit create channel, is it going to let me do it? No errors. Requires timecode config. I forgot about the timecode. We're going to do embedded, additional, the sync threshold. Just put 15 frames for now. For multiplex output video descriptions, height, I I forgot that it makes you specify the height here, 1920 by 1080.
But this would normally be templated, right? Or at least you could template
Yes,
this
yes,
in
of course,
advance.
you would template it.
Right, right. So we're doing it kind of manually here, but you can do all this otherwise.
And I'm going to do this 2 more times behind the scenes while Alistair's talking. And when we come back in a few minutes, you'll see, I'm hoping, a 3-channel multiplex. So I'm just going to hit start on this guy right now. It'll start. Can you talk about IRDs for a few minutes while I work on this?
Give me the slide back.
Yeah, I'll just go like
I think the
that.
important point here is, you saw what was involved in building a multiplex. Completely different to what we've been doing up to date, right? Where you've got racks and racks of gear, tons of wiring. I mean, just a very complicated, all the way from sort of speccing equipment to putting in purchase orders to racking and stacking gear. I mean, months and months of work, right? You can see here, I mean, it's sort of minutes, right? And it's built. So that's pretty impressive. So let me continue stepping through here. So IRD technology, right? For those not familiar, integrated receiver decoder. This is the satellite receiver that we use. This is a photograph of the one we use today. It's a DSR 6000. Again, in its day, great. Did a really good job, super reliable, but it only took a satellite input, and it was only one single channel per box. So if you were a cable operator and you had multiple channels, you just had racks and racks of this stuff, and that just eats up space. This particular unit does not do a decode, so its output is an MPEG transport stream. But again, it was pretty reliable in its day. But we want to do new things, right? We want to do 4K. We want to do a bunch of new stuff. So 2018, that shot there is the receiver, the IRD we're using for this project, which is made by a company called MediaKind, which, if you don't recognize that name, they're formerly Tandberg, formerly Ericsson. I mean, they've been around a long time in the IRD business. What makes this unit so special is it's software defined. So it's basically running on a COTS, a commercial off-the-shelf server. It does have plug-in PCIe cards at the back, 4 in fact in total, to give it an RF input, to give it the right I/O, etc. It also has a CAM module, which is a conditional access module, which again is a little different to how it's been done traditionally in the US, where the manufacturers, including in 07, have a proprietary encryption system. 2018, this box, this RX1 box with a CAM module, can take any flavor of encryption that we want to use. So we're choosing in this case to use a European company called Irdetto. If, heaven forbid, it were to be compromised, then we can change to a different one. I mean, it's basically changing a card in the module. And Nagra Kodelsky, there's a list of them we could use. So point is, you're not locked into one encryption system, whereas in the past you were. Another important point to make with this box is that we're using 2 variants. The broadcast variant is still going to be a single channel box, but it'll do quite a bit. It'll do a full 4K decode with quad 3G outputs or a single 12G in the later phase, and it has other features that are very broadcast sort of oriented. But it's a single channel box. The cable box, however, is a different animal. So again, in the past, we'd provide racks of these single channel units. This one, for the cable side, is licensable up to 12 channels in a single box, and we can actually transmit the licenses over the satellite feed and remotely enable all these new channels. So we've got number one, obviously, a huge space savings, but the flexibility of adding and subtracting licenses, which is very important. Another thing that's good, it's software defined, right? So we've built in connectors on the rear panel that on day one don't have a function. I mean, they're connected into I/O ports on the motherboard, but they've not been assigned a function. Down the road, we can send new software to the receiver and actually activate those ports, with whatever function we need. So it gives the ability to introduce new features, which is super important. So again, very very flexible. Okay, so again, we've been talking. This is the diagram you saw before. We've been talking about the area in orange, and of course then the question is, how does this map to Amazon? And I think this is where we're getting back to your piece, or we still have...
Keep going.
Keep going, okay? Still creating the mux. Okay, so let me talk about our actual project in a bit more detail. So starting in February of next year, we actually start the rollout of HEVC in the first phase to our broadcast affiliates. We have 208 broadcast affiliates, 17 we own, Fox Corp owns, the other 191 are owned by the station groups like Sinclair, Nexstar, et cetera, et cetera. So we're going to roll out to those guys starting February, 3 receivers per broadcast station. We have a lot of other tasks to do, but that's what we're going to be rolling out. So just following through on this diagram. So in this early phase, because this is so new, there is still work ongoing. So in this early phase, we're going to have more hardware on premise in in LA and in Phoenix, which is where our broadcast facility is being built. More hardware on-prem than we would down the road. So the leftmost box that's labeled at the top, Fox NOC, there are contribution encoders, Elemental Live encoders there, sending out 80 megabit mezzanine streams per network. There'll be 16 slices, if you will, 16 feeds fed via the cloud, ultimately using a direct connect. In the early POC days, it was actually using internet with a Zixi error correction, but ultimately by a direct connect. And that will go into the cloud. We're using 2 availability zones in US West 2 and 2 more in US East 2 in Ohio. So we've got a massive amount of redundancy for sure. In this, again, early phase here, so we've got more on-prem. So once the encoding and multiplexing has been done in the cloud, we're going to take that feed back out of the cloud, back via direct connect, back to LA and Phoenix, to some MediaKind remultiplexing equipment. We have to do that because we have to add in the encryption keys, and we have to add in the control layer, the control plane that actually controls the IRDs. So in order to do that, we have to remux. So there's going to be equipment, and you can see in there, right? The MKSP MUX is MediaKind MUX, encryption key server, and the NCC Director is the box that does the actual IRD control. The output of all of that MUX is then fed into modulators. You can see there the M6100, which is a new tech product that modulates it to RF, and then it goes out to the satellite, and then down on the far right to the RX1s, the IRDs. So that is phase 1, which for us is running from February to say end of July. We have to be pretty much done by that because the next NFL season starts, and we don't want to be rolling these out when that's on. So the second phase is important because if you look to the far left of the diagram here, you'll see cloud play out. So we're not stopping at doing just encoding and muxing. The idea is to put as much in the cloud as we possibly can, including scheduling and automation, play out. Everything, in our view, needs to be in the cloud. That's sort of the first question we ask ourselves is, can it be done in the cloud? If it can, then that's what we're going to do. So you can see on that diagram, that's what we're doing here. Still a requirement to remux and encryption keys, et cetera, modulate satellite. So that's, again, main difference is more stuff upstream lifted to the cloud. Okay, did you want to do your thing with this?
Yeah, sure.
Stuff. All right.
So we teased this early. The point of this slide is we've talked a lot about so far the timeline of the history of television. Alistair spoke to the timeline of the history of Fox. And the point I want to impress upon everybody now is that you're witnessing in real time the merging of us. This is a partnership coming together at this point. Actually, the press release came out this morning, didn't it? Yeah.
Oh, it
so
did?
yes, it did.
I didn't know that.
I haven't had time to read it, but AWS and Fox are teaming up to do this formally, and in 2020, next year, as Alistair just described to you, Fox is going to be the first major network originating real live television from the cloud, and we're very, very excited about that, and
Yep.
all that brings with it. Furthermore, because StatMux in the cloud wasn't a reality even a week ago, you were all the first people to experience seeing that. So now you're part of this timeline, if you will. So thank you for being here and witnessing that and doing that with us. I'd like to show you the workflow of the demo that we're going to show you in a second. Basically, what's happening here is that we have the encoders on-prem in Pico, like I said, contributing 80 megabit contribution sources, HEVC encoded, to AWS. And it's going through the Media Live service and then into the StatMux. And as Alistair was explaining before, you see 2 instances, one Media Live and then one Media Live StatMux instance, because the encoders are running and the StatMux instance is controlling the rate of the output of those encoders. And there are multiple encoders feeding into the multiplexer so that on the output, you get the sum is a flat bit rate, but what's in it is fluctuating. And Alistair will explain that graphically in a moment. And the last thing to know is for this demonstration, there are 2 other EC2 instances that we've built for you. The top one is an analyzer. So we're going to analyze the stream that we've created that's coming out of the cloud. And the bottom one is a multi-viewer, which is a common monitoring tool that broadcasters use to monitor multiple video streams at the same time, some of which you saw in the video earlier. Everybody sits in front of these multi-viewers. That's how you get these massive video walls with hundreds of pictures going on. So we have one of those that we've spun up in the cloud too. So we'll show you that. And actually, good news. Here's a 3-channel multiplex. This didn't exist like 10 minutes ago. And these are just the 3 that I picked. I'll show you a diagram that comes with this application. If I can find it, the chart, the stacked area. And Alistair, maybe you can explain a little bit about what they're seeing here.
Right. I guess we don't have an 8-channel one that was templated.
Oh,
previously,
I do.
Because that way the usage, the MUX usage would be
let's do that.
more impressive.
I just have to switch to the one.
So that was a 3-channel MUX. We have an 8-channel MUX that we can show you, and that, for the purpose of discussing the MUX allocation, that's a better demo.
Sorry about that.
You just woke everybody up, Evan.
You know what? I changed the input and the application got upset. But here's the 8-channel MUX that we built earlier.
Perfect. Okay.
So this is all 8 channels coming up from Pico.
All live from LA, right?
Yeah, all live. Yep.
Yep. And then you've got that the MUX diagram, right?
There you go.
Perfect. Yep. Okay. So remember we talked about the encoders being throttled up and down by the MUX controller based on scene complexity. That's what you're going to see here as this diagram builds. Each of those colored bands is a channel, and you can see they're varying in real time depending on the sort of the complexity that's assigned to each of the channels. And so now you're seeing it in real time, and it's just super impressive. I think this is the 5th rollout of new hardware of this kind that I've done in my career, and this is the most interesting, I think, because it's the biggest leap in terms of technology. Doing this in the cloud is super impressive.
Thank you. There's one thing I want to add. If you've never built a StatMux before, then you don't know that what I just did in 10 minutes used to take a year. I mean, I'm not exaggerating.
It can be a long time,
because you have to think about it. You have to go. You saw the racks of gear. You have to go. You have to figure out where you're going to put it. You have to order it. You have to wait for it. Mm-hmm. You have to schedule maintenance windows in the middle of the night just in case somebody trips over a wire. I mean, on and on and on. And then the vendor has to show up and commission it for a month. And it's this whole thing. And this I wish when I was a customer that I had this. I really do. I really do wish it because it's just so easy.
Yeah.
And I like that.
Yeah.
And then, of course, the...
and one of the points I was going to make was we're designing this so that we'll have some of our channels, some of our transponders loaded with, with an 8-channel MUX where everything's sort of standard HEVC, standard resolution. But if we, but in another transponder, we have the ability to mix and match a 4K signal with a smaller group of HEVC channels. So again, building that MUX and reorganizing that MUX to spin up a 4K and add it into a MUX, then remove it from the MUX at the end of the event is huge. So that is going to be just a really sort of a game changer.
And the ability to go global.
Yes.
Yeah, I mean, I built it in Oregon because that's the closest region, and we wanted it to happen quickly. But Fox could launch a MUX tomorrow in London if you want.
Yep. And there's the clock that proves it's real time, right?
There's the clock that proves it's real time. These channels are playing out of Fox channel chains right now in LA. I'm glad we were able to share this with you today. Excuse me. Going back over here for a moment, just to wrap up.
Yep. Got one more slide, do I?
You have one more slide. We want to talk about, we talked about the history. We talked about what we have available today, how we're changing the industry today. We want to talk about one more thing, which is what we're going to do next.
And I think we sort of touched on it before, right? Yeah. I mean, we've we've already covered sort of the encode and mux piece that I think we've certainly shown you today. There's obviously a lot more we can do, right? We can do play out in the cloud, which is absolutely a current project ongoing, and certainly by Q3, let's say, of next year, that's very much going to be reality. But it doesn't stop there. We can do an awful lot more, right? The intent is to put in the cloud literally as much as we can. If we can get the production control unit, control room in the cloud, we will. And ultimately, right, the truck as well. I mean, we've talked about whether that would be possible as well. You get a good bandwidth connection at a venue. You can literally spin up a virtual production truck and do everything in the cloud. That is the goal. I think there's one more slide.
There's one more, but we got to wrap.
Yep.
Very briefly. This is where we see this going in the next 5 years or so. Basically, we've worked our way from the right of the diagram to the left, starting with CloudFront, for example, as a CDN to carry video. We added those media services back in 2017 that enabled people to do encoding, packaging in the cloud, what have you. And as we continue to improve upon the technology, get that latency down, get that reliability up, we're going to be able to do very interesting things, spinning up production control rooms in the cloud on the whole with the CloudFront formation, for example. That could be very real in 5 years from now. And we're already starting to work with the vendors in the broadcast space to design their applications to run in AWS in this way, so that you could theoretically take those cameras from the field at the stadium that we saw and send a low latency codec right from the field to AWS and do your entire production and have your crew be anywhere at workstations. And that's it. Then they made me put this slide in. If you're interested in media services, you want to learn more, here's the training link. Please do check it out. Thank you for being here, and please complete the session survey. Give us a good score. Thank you very much.